Now we are going to learn Bohr model of atom. Niels Bohr gave the quantitative explanation of the structure of hydrogen atom. At first, it was based on hydrogen spectrum and quantum theory. Important postulates of Bohr model of atom or Bohr theory are the following. 1. Atom consists of a positively charged center called nucleus, and electrons are revolving around the nucleus. In certain circular paths called stationary orbits. So, electrons are revolving around the nucleus in certain circular paths that are called stationary orbits. The second postulate is this. Different stationary orbits are at different distances from the nucleus and they have different energies. Each stationary orbit has a fixed energy and a fixed radius. So, different stationary orbits are at different distances from the nucleus. Third point. The energy of the orbit or energy of an electron in an orbit does not change with the time. That is, an electron remains in the same stationary level until it gains or loses energy. If it gains energy, it jumps up to a higher energy level. If it loses energy, it jumps down to a lower energy level. So, energy of electron in an orbit does not change with the time. Then fourth postulate is this. An electron absorb or emit energy in discrete packets that are called quanta. A quantum of energy is expressed by the equation E is equal to h nu, where E is a quantum of energy, h is Planck's constant, and nu is the frequency of radiation. That is, the energy of an electron in an atom is quantized. Then fifth point, see the difference in energy between two stationary levels, two adjacent stationary levels can be expressed by the equation delta E is equal to E2 minus E1. And this energy is equivalent to h nu. So we can say that delta E is equal to h nu and nu is equal to delta E divided by h. See, this equation is called Bohr frequency rule. Nu is equal to delta E by h. This equation is called, or this relationship is called Bohr frequency rule. Then sixth point. See, Bohr calculated the angular momentum of an electron in an atom. According to the expression, mvr is equal to n into h by 2 pi, where m is mass of the electron, v is velocity of electron, r is radius of the orbit, n is number of orbits, and can have the values 1, 2, 3, 4, etc. Integers like 1, 2, 3, 4, etc. And you know that h is Planck's constant. From this it is clear that the value of the angular momentum will be an integral multiple of h by 2 pi, that is a constant. H by 2 pi is a constant, and integral multiple of h by 2 pi. That is, the value of MVR is equal to 1 into h by 2 pi, or 2 into h by 2 pi, or 3 into h by 2 pi, and so on. Never it will be fractional. From this, it is clear that the angular momentum of the electron is also quantized, packetized. Therefore, two important highlights of Niels Bohr atom model are quantization of energy, that is packetization of energy, and quantization of angular momentum or packetization of angular momentum. That's it. Merits of Bohr model of atom. 1. It could explain stability of atom. Stability of atom. It is because an electron has an energy in a particular stationary level, and this energy does not change with time until the electron absorb or emit radiations. That is why the Bohr model could explain the stability of an atom. Second point is, it could explain the spectra and why many lines are obtained in spectrum. It can be explained as follows. When hydrogen gas is filled in the discharge tube and subjected to electric discharge, excited hydrogen atoms are produced. These excited hydrogen atoms may have different energy levels. In some atoms, the electron may be in first level and absorb energy, jump up to a third level. This level is unstable, so it may jump down to the second or first level by losing energy in the form of electromagnetic radiations. These electromagnetic radiations produce lines in the spectrum. Consider another atom in which the electron is in the second excited state, already in the second excited state. If this electron absorb energy and jump, it may go to third or fourth level or even a higher level. But these states are unstable, so the electron will jump down to the lower energy levels. Therefore, many atoms may have electrons in many levels. Therefore, hydrogen spectrum contains a large number of lines. We cannot take hydrogen spectrum using a single hydrogen atom, but a large number of hydrogen atoms are considered while taking the hydrogen spectrum. Third point, Bohr could calculate the energy of the electron as En is equal to minus 2 pi square m e raised to 4 into z square by n square into h square. This equation is called Bohr energy equation. Here En stands for the energy of the nth orbit. M stands for the mass of the electron. Mass of electron. E stands for the charge of electron. Z stands for atomic number. N stands for number of orbits. H stands for Planck's constant. See, when we substitute the values of 2, pi, m, e and h in this equation, we get En is equal to minus 1312 into z square divided by n square kilojoules per mole. See, this is the energy value when we substitute the value of these constants. See, this energy value can also be expressed in other units, that is, En is equal to minus 2.18 into 10 raised to minus 18 z square by n square joules per atom. See, this is in joule per atom and this is in kilojoule per mole. Now, the energy of the electron of the nth level can also be expressed in electron volt. It is minus 13.6 into z square by n square electron volt per atom. Electron volt per atom. That is the value of energy of the nth level in hydrogen atom in electron volts. See, all these values are the same, but they are in different units. Now, if we calculate the energy of each electron or energy of the electron in each orbit, see, if n is equal to 1, see, E1 become minus 1312 into Z is, for hydrogen Z is 1. So 1312 kilojoules per mole. If n is equal to 2, E2 is equal to minus 1312 by 2 square, that is 4 kilojoules per mole. See, from this it is clear that as n value increases, the negative value of energy decreases. That is, the positive value of the energy increases. The energy value is minimum when n is equal to 1. This state of the atom is called ground state. But as the value of n increases, the energy values increases. That is, positive energy value increases. These values are called, or these states are called, excited states. Merits of Bohr model continues. Fourth point, the difference in energy between two stationary levels can be expressed as delta E is equal to E2 minus E1 is equal to h nu, that is h nu is C by lambda, so hc by lambda. Therefore, we can say that hc by lambda is equal to, say, E2 minus E1. E2 is minus 2.18 into 10 raised to minus 18. Z is 1 for hydrogen. So 1 by, say, E2, N2 square minus 2.18 into 10 raised to minus 18 into 1 by N1 square. It's for E1. This is the energy of E1. This is the energy of E2. Therefore, we can say that hc by lambda is equal to, see, minus of minus plus, and 2.18 into 10 raised to minus 18 become the common factor. So 2.18 into 10 raised to minus 18 into, see, this become positive term. So 1 by n1 square minus 1 by n2 square. And we can say that 1 by lambda is equal to 2.18 into 10 raised to minus 18 by h into c. H into c into 1 by n1 square minus 1 by n2 square. Substituting the values of h and c here, that is 2.18 into 10 raised to minus 18 divided by 6.626 into 10 raised to minus 34 into 3 into 10 raised to 10. See, this is 3 into 10 raised to 10 centimeter per second into 1 by n1 square minus 1 by n2 square. See, this is 1 by lambda, that is reciprocal of wavelength. The reciprocal of wavelength is called wave number. So it is wave number. It is expressed as 1 by lambda is equal to nu bar. Therefore, nu bar is equal to, doing this calculation, we get 0.1096689 into 10 raised to 6 into 1 by n1 square minus 1 by n2 square. So this is 0.1096689 into 10 raised to 6. This can be expressed as nu bar is equal to 109668 into 1 by n1 square minus 1 by n2 square. And you know that this is Rydberg constant. This centimeter inverse is Rydberg constant. So nu bar is equal to RH into 1 by n1 square minus 1 by n2 square. This is the same as the Rydberg relationship. Therefore, Bohr model of atom is in agreement with the Rydberg relationship. That is one of the important merits of Bohr model of atom. Merits of Bohr model continues. Fifth point, he could calculate the radius of Bohr orbit, that is radius of orbit of hydrogen atom. It's expressed by the equation Rn is equal to n square into A0 by Z. See, this is the, where Rn is the radius of nth level, radius of nth Bohr orbit or nth orbit. N is an integer like 1, 2, 3, 4, etc. It stands for the number of orbit. And A0 is, value of A0 is 52.9 picometer, or it is equal to 0.529 angstrom units. Therefore, Rn can be expressed as, for the first orbit, R1 is equal to 1 square into A0, that is 52.9 picometer. Why? Because A0 is 52.9, N is 1, Z is 1. For hydrogen, Z is 1. And R2 is expressed as, see, N is equal to 2. So 4 into 52.9 picometer and so on. So, Bohr theory could calculate the radius of the orbit of nth level. Sixth point is that he could calculate the velocity of electron. and it is calculated using the formula Vn is equal to 2.18 into 10 raised to 6 Z by N, where Z is the atomic number and N is the number of orbit in which the electron is present. Vn is the velocity of the nth level. From this expression, it is clear that the velocity of the electron increases with an increase in Z value, with an increase in Z value. But the velocity of the electron decreases with an increase in n value. Why? Because velocity is directly proportional to Z. So, as Z value increases, velocity also increases. But velocity is inversely proportional to the number of orbits. Therefore, velocity decreases with increase in number of orbits, that is value of n. These are the important merits of Bohr model of atom. Let us learn demerits of Bohr model of atom. First point. See, Bohr model could explain, even though Bohr model could explain the spectra of single electron systems like H, He plus, Li2 plus, etc. It fails to explain spectra of multi-electron systems. It is because their spectra are complex. That is, the systems containing two or more electrons. The spectra of systems containing two or more electrons are complex. And their spectra are not explained by Bohr model of atom. Second demerit, it fails to explain fine spectrum. What is fine spectrum? When a high efficient spectroscopy is used or high resolving power spectroscopy is used, the lines in spectrum divides further, and thus obtained spectrum is called fine spectrum. Bohr model fails to explain fine spectrum. Third point, Bohr model fails to explain the splitting of, spectral lines in external magnetic field. When an external magnetic field is applied, the spectral lines will split further. This is called Zeeman effect. So, Bohr model fails to explain Zeeman effect, that is, splitting of spectral lines in external magnetic field. Fourth point, Bohr model fails to explain Stark effect. That is, the splitting of spectral lines in an external electric field. The splitting of spectral lines in an external electric field is called a Stark effect. Bohr model fails to explain Stark effect. Fifth point, it fails to explain chemical bonding and molecular structure. Chemical bonding and molecular structure. Sixth point, it fails to explain Heisenberg uncertainty principle. And de Broglie wave equation. See, we are going to see Heisenberg uncertainty principle and de Broglie wave equation before the next model of atom. Now we can do some problems based on Bohr model of atom. Question: calculate the energy associated with second Bohr orbit for H HE single plus and Li 2 plus. See, we are asked to find or calculate the energy associated with the second Bohr orbit of three species, namely H, He plus and Li 2 plus. See, Bohr energy equation is expressed as En is equal to minus 2.18 into 10 raised to minus 18 Z square by N square. For hydrogen, the energy of the second Bohr orbit is expressed as E2 is equal to minus 2.18 into 10 raised to minus 18 into Z is equal to 1 for hydrogen. So 1 by second Bohr orbit 2 square, that is equal to minus 2.18 divided by 4 into 10 raised to minus 18. That's equal to minus 0.545 into 10 raised to minus 18 joule per atom. For He plus, the energy of the second Bohr orbit is expressed as E2 is equal to minus 2.18 into 10 raised to minus 18 into, for He plus, Z is equal to 2, so 2 square by 2 square. That is equal to minus 2.18 into 10 raised to minus 18 joule per atom itself. For Li 2 plus, the energy of the second Bohr orbit is expressed as E2 is equal to minus 2.18 into 10 raised to minus 18 into, say, Z is equal to 3 for lithium. So 3 square divided by 2 square. That's equal to minus 2.18 into 10 raised to minus 18 into 9 divided by 4. That's equal to minus 4.905. 2.18 into 9 by 4. See, into 10 raised to minus 18 joule per atom. See, from these three values of energy, it is clear that the negative value of energy increases from H to Li2 plus. But the positive energy value decreases. Therefore, the energy value decreases with the increase in atomic number. That is, positive energy value decreases with the increase in atomic number. See, for Li2 plus, the positive energy value is minimum. But for He plus, but for H, the positive energy value is maximum. From this, we can attain this generalization, that is, for a given n value or given orbit, the energy, that is positive energy value, decreases with the increase in atomic number. That's all. Another question. Calculate energy of first and second Bohr orbit of He plus. See, we are asked to calculate the energy of the first and second Bohr orbit of He plus. We know that energy of the electron of nth level according to Bohr model is En is equal to minus 2.18 into 10 raised to minus 18 Z square by N square joule per atom. See, for first Bohr orbit of He plus, E1 is equal to minus 2.18 into 10 raised to minus 18. See, Z is 2 for He plus. So 2 square by 1 square joule per atom. See, its value is 2 square 4. Its value is minus 8.72 into 10 raised to minus 18 joule per atom. For second Bohr orbit of He plus, the energy value is expressed as E2 is equal to minus 2.18 into 10 raised to minus 18 into Z is 2 square by 2 square, because it is because the orbit is second, so n is equal to 2. See, 2 square getting cancelled, we get minus 2.18 into 10 raised to minus 18 joule per atom. See, from these two values it is clear that the positive energy values increase with the increase in number of orbits, n value. Here n is 1, here n is 2. The positive energy value is higher for the second Bohr orbit. Therefore, the energy value increases with an increase in n value for a given species. That's all. Question. Calculate radius of Bohr orbit of first and second level of He plus species. See, we are asked to calculate the radius of the Bohr orbit when electron is present in the first and second level of He plus. See, He plus is a single electron species and it obeys Bohr theory. And for Bohr model of atom, radius of the orbit is expressed by the equation Rn is equal to n square into a0 divided by z, where Rn is the radius of the nth level, n is the number of orbit, a0 is equal to 52.9 picometer. Z is the atomic number. For first Bohr orbit of of He plus. R1 is equal to n is 1. So 1 square into 52.9 divided by, for He plus, Z is equal to 2. That is 52.9 by 2 is equal to 26.45 picometer. For second Bohr orbit of He plus, R2 is equal to, say n is equal to 2. 2 square into 52.9 divided by 2. See 2 getting cancelled off, we get 2 into 52.9 divided by 9, that is equal to 105.8 picometer. See, from these two radius values, it is clear that the radius of a given species, for a given species, radius increases as the value of n increases. For a given species, the radius value increases as the value of n increases. See, if n is equal to 1, radius is this. But when n is equal to 2, radius value is this. This is higher value. So, as n value increases for a given species, the radius value increases. Radii will increase. Another question. Calculate the radii of second Bohr orbit for He plus and Li2 plus species. See, both of them are single electron systems, so they obey Bohr theory. Therefore, radii can be calculated using this relationship. Let us see for He plus, the radius of the second orbit can be expressed as R2 is equal to, see, n is equal to 2. So 2 square into 52.9 divided by, for He, Z is equal to 2. 2 getting cancelled off, we get 2 into 52.9. That is equal to 105.8 picometer. Now, let us check the value of radius of the second Bohr orbit for Li2 plus. See, radius of the second Bohr orbit is expressed as, see, n is equal to 2. 2 square into 52.9 divided by, Z is equal to 3 for Li2 plus. So 3. That is equal to 4 into 52.9 divided by 3. That's equal to 70.533 pm picometer. See, this is the radius of the second Bohr orbit of He plus. This is the radius of the second Bohr orbit of Li2 plus. From these two values, it is observed that the value of radius of a given orbit for a given n value, a radius value decreases with an increase in atomic number. calculate ionization energy for one hydrogen if N is equal to 1 and hydrogen if N is equal to 5. See, we are asked to find the ionization energy or ionization enthalpy for a hydrogen if electron is initially present in first orbit and if electron is initially present in the fifth orbit. See, ionization energy is the energy required to remove an electron to the infinite level by bringing out of the nuclear force of attraction. Therefore, if electron is present in the first level, some energy must be supplied to break the force of attraction between nucleus and electron to bring the electron to the infinite level. We are asked to find that much of energy. In the case of this hydrogen atom where electron is initially present in the fifth level, say electron is already present in the fifth level. One, two, three, four, 5. Electron is already present in the fifth level. We must supply some energy to break the force of attraction between nucleus and electron to bring the electron to the infinite level. That much energy is the ionization potential if N is equal to 5. Let us calculate them. If N is equal to 1, then ionization energy is expressed by the equation delta E is equal to, see, final state is E infinity minus, initial state is the first level. Substituting the values here, minus 2.18 into 10 raised to minus 18 into Z is 1 for hydrogen and level is infinity, so infinity square, minus 2.18 into 10 raised to minus 18 into Z is 1 and first level. See, this is 0. Why? Because 1 by infinity, any number divided by infinity is equal to 0. Minus of minus become plus. So plus 2.18 into 10 raised to minus 18 joule per atom. This will be the ionization energy for hydrogen atom if electron is initially present in the first level. See, if electron is present initially in the fifth state, then ionization enthalpy is equal to delta E is equal to E infinity minus E5. That is minus 2.18 into 10 raised to minus 18 into 1 by infinity square minus 2.18 into 10 raised to minus 18 into 1 by 5 square. See, this term becomes 0, minus of minus become plus. So we get plus 2.18 into 10 raised to minus 18 divided by 25. See, this is expressed as 0.0872 into 10 raised to minus 18 joule per atom. Plus value. So the ionization enthalpy is higher when N is equal to 1 and ionization enthalpy is less when N is equal to 2. From these values we can attain a generalization. That is, the ionization enthalpy or energy decreases. Ionization enthalpy value decreases with the increase in N value for a given species. That is, for a given species, for hydrogen, the ionization enthalpy is decreased. That is, the ionization enthalpy is less when n is equal to 5. Therefore, ionization enthalpy decreases with increase in N1 value. That's question. Calculate ionization energy for H and He plus species when electron is in first Bohr orbit. See, we are asked to find the ionization enthalpy or ionization energy for H and He when electron is present in the first Bohr orbit in both the species. See, for hydrogen, when n is equal to 1, the ionization enthalpy or ionization energy is expressed as I is equal to delta E is equal to E infinity minus E1. That is, I is equal to, ionization enthalpy is equal to minus 2.18 into 10 raised to minus 18 into 1 square divided by infinity square minus 2.18 into 10 raised to minus 18 into 1 square by 1 square. See, this term becomes 0, minus of minus become plus. So, plus 2.18 into 10 raised to minus 18 joule per atom. This will be the ionization energy for hydrogen when n is equal to 1. Now, for He plus species, when n is equal to 1, ionization enthalpy is expressed as, or ionization energy is expressed as, delta E is equal to E infinity minus E1. That is equal to, that is ionization enthalpy is equal to minus 2.18 into 10 raised to minus 18 into Z is 2 for He plus, so 2 square by infinity square minus 2.18 into 10 raised to minus 18 into 2 square by first level, so 1 square. See, this term becomes 0, so minus of minus become plus, that is plus 2.18 into 10 raised to minus 18 into 4. That is equal to 8.78 into 10 raised to minus 18 joule per atom. See, this will be the ionization enthalpy when n is equal to 1 for He plus. From these two energy values, ionization enthalpy values, it is clear that the ionization enthalpy increases. The ionization enthalpy value increases with the increase in Z value for a constant n value, that is for a particular Bohr orbit. Okay.